Hello students, welcome back to Turito's live classes. Students, we have completed the first chapter of grade 9th, which was matter around us. Are you all able to recall the concepts which we discussed in the last chapter? Okay, so we have discussed about matter, like what is matter, and then we talked about some different properties of matter, correct? So we have seen a classification of matter too. In today's session, we are going to start with the brand new chapter of grade 9th, which is nothing but what? Is matter around us pure? What do you think? If I am asking this question, though it's our chapter, okay, so this is what is our second chapter for grade 9th. So my question to you is that, is matter around us pure? What do you think? Let's suppose I am taking example of milk. You must have seen that it is written on that package, it's like pure milk, okay, pure ghee. So these are some pure substances which we use. What do you think? These are substances are pure? Are they really pure? In this session or in this chapter, we are going to find out an answer for this question: is matter around us pure? Okay, so are you all ready? Soon we are going to get started with the new chapter called as Is Matter Around Us Pure? Okay, so just grab your notebook and pen so that we can quickly go through the learning objectives, like how our today's session will be looking like. All right then. So students, in this class or in this session, we are going to understand, we are going to learn new concepts such as classification of matter. Okay, so how we have classified matter. Then we are going to talk about physical and chemical classification of matter in detail once again. Then we are going to understand what pure substances are. Okay, for us, the milk which we are using, maybe it's a pure. Okay, for a common man, things which we are using are pure, but what a scientist has to say about that purity of milk. Okay, so how we define purity. Okay, so here in this point or in this chapter, we are going to talk about pure substances, what pure substances are. Then we are going to learn about something called as elements. Have you heard about elements? Give me some example of elements if you know. Any one of you can give it. Okay. Oxygen, some are typing, or hydrogen too. Yeah, they are elements, but how? What are the properties of these elements, or what these elements are? We are going to discuss it in detail. Moving ahead, we are having next point or next topic to talk about or to understand about is what? Compounds. What compounds are? See, the motto and the purpose behind this classification is that we are surrounded by many or various matter. There are so many matter which we are surrounded by. If one needs to study the different types of matter, definitely we have to classify the matter. Okay, so that's where we are going to understand these are some types of matter basically. Okay, then we are having mixtures, a different category of matter. Now what mixtures are and what are their properties, or maybe they are having different types too. We are going to cover about it soon. Okay, so students, first of all tell me what do you mean by a matter is quickly. I need that definition from each and everyone. Come on, tell me what do you mean by matter is. How do we define any matter or any substance? Matter is any substance or it is anything which has its own mass, right? And it occupies its own space, correct? So matter is something which we can perceive by our senses, which we can feel, which we can see, right? Or it has its own mass which can occupy its own space. That thing is nothing but matter. Right now I am holding these two things, a marker and a remote. I can say these are example of matter. Okay, so we have a detailed discussion about matter and examples too. correct? Even we studied about some properties of particles of matter. There we discuss about the physical nature of matter, right? So we know that matter is particulate in nature. It is consist of small particles, correct? So yeah, that was a very long session, and we have talked about each and every property which is regarding to matter, correct? So after knowing the matter, students, it's very necessary, it's very important to understand that how we have classified matter into various categories. Okay. So yes, matter is divided into two categories, physical and what? Chemical. Physical classification of matter and chemical classification of matter. So physical classification is based on the physical property. So here the property which we are interested, or the physical classification, is based on states of matter. States of matter. Okay, this is what is the physical property which based on which we have categorized matter into different subcategories. Okay, now depends on the, or based on the states of matter, tell me how many states do we have majorly? Okay, so yes, solids, we have liquids, and we have gaseous substances or gases, right? So first classification is what? Physical classification, and physical classification is based on what? Physical properties. Now let me recall about the physical properties. Physical properties are that properties of any substance which we can see, which we can observe, which we can measure, such as color, size, shape, state. Okay, right now I'm having this marker, it's white in color, okay, and it has black color too, it's cylindrical in shape. Okay, so it's a solid, hard to touch. So what these properties are? These are physical properties, correct? So based on physical properties, matter is divided into the first category is what? Physical classification, which is based on physical properties. So which physical property we are talking about? We are talking about what? States of matter, such as what? Solids, liquids, gases, plasma, BEC, etc. So far, five state of matter which we have categorized the matter into, correct? So that is your physical classification. Moving ahead, let's try to understand the chemical classification of matter. Chemical classification. Okay. So I need some answers from you, like chemical classification is based on chemical properties, right? Those who know the answers, you can type your answers in the chat box, okay, so that I can see how many of you all are able to recall whatever we have covered. So chemical classification is based on the chemical properties of any substance. Now you must be saying, ma'am, what chemical properties are? So students, we have seen chemical properties are that properties of any matter, okay, suppose the ability to react. It can be considered as like I told you that it's related to its chemical composition, or internally how the particles are arranged, what's happening inside the matter. So there are some properties which are going to discuss, which are going to comment on the internal structure of matter, okay, how this substance is going to react. That's what chemical reactivity of a substance, which is also a chemical property. Okay, how geometric arrangement is there inside matter. Okay, how these particles are arranged inside the matter also can be considered as what? A chemical property. Okay, so point here is that chemical classification based on such chemical properties. Okay, also when we talk about chemical composition, okay, that is what is nothing but a pure, whether the substance is pure or impure. So what I mean is that based on the chemical properties such as what chemical composition, or I can write it as what based on the purity. Based on the purity of that matter of or a substance, we have classified matter into different categories such as, let me draw it, pure substances. Okay, what do we have? Pure substances is one of the category or subcategory. Then what will be the next? Impure substances, right? But you know what? In chemistry, we have given a suitable name for that. Now, what do you mean by impure? When there is addition of many things, okay, when it's getting adulterated, that is what our common man's language to understand impurity, right? But in chemistry, or for from a scientist point of view, we have given a proper name to impure substances, and which is mixture. What it is? Mixture. So basically matter is classified into, like, the second classification of matter is what? It is based on purity. So that's how we are having pure substances and mixtures. Are you able to follow till here? Matter is divided into two categories. Matter is divided into two categories. What these categories are? Physical classification and chemical classification. Focusing on category number 1, which is dependent on or which is based on physical properties such as states of matter. So we have subcategory solids, liquids and gases. Alright. Second classification is what? Chemical classification, which is based on chemical properties and purity or chemical composition. Based on chemical composition, we have subcategory such as what? Pure substances and impure substances. Quickly make a note of this. I hope it's clear for you all. Are you all able to see it? And try to understand, when we talk about pure substances, they are further divided into, I'll write here and here, elements. Okay, they are having further classification. Pure substances are further classified into two categories, elements and compounds. Elements and compounds. Okay. And yes, a mixture is also divided into two categories, homogeneous mixtures and heterogeneous mixtures. We are going to cover this part. Okay. Chemical classification, pure substances and mixtures in detail. So our class is based on the chemical classification thoroughly. Okay. I hope you have got an idea what we are going to learn today. We have just revised classification of matter. Now soon we are going to get start with the pure substances, what pure substances are. Okay, are you all ready? Have you all taken note of this chart? It's very important. Okay, so mark it as very important. Students, from this chapter onwards, whatever you are going to learn, I can say so that these are some fundamental or basics of chemistry. So give your full attention while understanding this chapter. Okay, so you are going to discuss important part of chemistry, which is nothing but basic of chemistry. So please do not ignore, give your complete attention and make a note of each and every point wherever you feel it's needed. Okay. Let's move ahead. Yeah, so matter can be classified into pure substances and mixture on the basis of their chemical composition. Alright. So here we are having pure substances and the second category is what? Mixtures. Got it? Now let's try to understand the first classification or pure substances in detail. Now tell me, what do you mean by pure substance? Like how do we define the purity? Purity from common man's point of view is something which has no adulterant in it, right? We just, let's suppose example of a packet of pure milk or a pure ghee, okay, or even your pure water, a Bisleri water which we drink, okay, they have written, they have mentioned it's pure water. So for us, if it is impurity less, or if there are no any adulterants, or if there is no any impurities in it, we say that particular substance is what? Pure. Correct? But in science, pure substances are like when a chemist or a scientist studies about pure substances, he has something different description for pure substances or for purity of any matter. So what it is, let's try to understand. So pure substance consists of single type of particles. Pure substance consists of single type of particle. How? Focus here. I am giving an example. Suppose I am having, if I am having iron rod, okay. Suppose this is how an iron rod looks like. Iron. What is the symbol for iron? Fe. Okay. This is what your iron rod looks like. It is consist of small atoms. Are you all agree with this? Okay, it must be having all these atoms. Okay. Each and every atom is consist of iron. Each and every like the composition of this iron rod has what? Iron atom. Okay. Did I write hydrogen? Did I write oxygen? Did I write copper? No. Throughout the chemical composition of iron rod, what we observe that it is composed of iron atoms. So that is what the first property of pure substance, that pure substance consists of single type of particle. This is what a single type of or same type of particle throughout its chemical composition. Got it? Substance is pure. Substance is a pure single form of matter. So this pure substance is a single form of matter. We are not going to add any other atom into it. Okay, in nature we are having some pure substances which are made up of only same kind of atom, or they are made up of single type of particles. Okay. Next point is that it is homogeneous in nature. Okay, homo, that means same. Homo means same. Consider here, we are going to stick with this example only. If I am saying that it is iron, okay, so definitely this rod has iron atoms throughout its chemical composition, and imagine how it looks like. Appearance wise, it's homogeneous. That means it looks very similar. Okay, I am not able to differentiate among the layers, among the borders. Okay, I am not going to see, is there any boundaries which we are able to see? No, it's a complete or it's uniformly spreaded substance. Okay, so I do not see any different phase in it. Correct? So that this becomes your homogeneous substance which is in nature. Okay. Then next is pure substance has definite state of properties such as sharp melting point and boiling point. Students, try to understand whenever we talk about pure substance are made up of one kind of atoms or similar or same kind of atoms. Okay, I have given, just let's try to stick with this example only so that you will get it in a better way. Okay, we have seen example of iron rod, and this iron rod is made up of small atoms which are like all are similar. They are homogeneous in nature. So let's suppose we are going to supply some heat to the this rod. Okay, we are going to melt. We want to melt this iron rod. Okay, so it won't happen. Okay, suppose this is atom number 1, this is atom number 3, this is, okay, so let's suppose try to give number to this atom. Practically we are not able to do that, but for your understanding I am just doing it. Okay, atom number 1, atom number 2, atom number 3, these are 3 atoms. Okay, they are absorbing the heat. What do you think? Suppose atom number 1 is getting melted at x degree Celsius, okay, some melting point. What do you think atom number Y is going to get melted at y degree Celsius? Atom number 3 is going to get melted at z degree Celsius. Is it going to happen? What do you think? What do we see? X, Y, Z. These are 3 different melting points for a single substance. No, right? If one atom is getting melted at 0 degree Celsius, throughout this substance, or this substance wholly or completely is going to get melted at x 0 degree Celsius. X degree Celsius. What did I say? It has a sharp melting point. All these atoms are going to get melt at x degree Celsius. It can be any temperature. Okay. So students, try to understand, whenever we study about pure substances, they are having their own properties. Properties such as sharp melting point. See, they are not going to melt in the range. They are, like suppose, what do you mean by range is that, suppose 200 to 300 degrees Celsius. Okay, this is what is a range. Okay, it is not sharp melting point or a boiling point. If I am saying that a substance is getting melted at 215 degrees Celsius, this becomes your sharp melting point or boiling point. Okay, the value or the temperature is fixed. And where do we see? We see this property in pure substances. Okay, so basically this range we oftenly observe in case of mixtures. So basically what mixtures are? They are made up of so many things, but here our pure substance is made up of one single type of particles, and that's why they are having their own set of properties such as sharp melting or either boiling point too. Are you all able to follow? Is there any confusion? If a substance is made up of so many things, if it is made up of so many components, definitely like there are very less chances that the melting point of that substance is rigid or it's firm or it's very sharp. No, it may vary in certain range. Okay, it can get like 210, 215, etc. till 300 degrees Celsius. But when we talk about pure substance, they are going to get melt or they are going to get boiled at certain temperature, which is sharp. Okay, is there any confusion between sharp temperature or temperature range? Do not get confused. It's all depend on the chemical composition. All right. Moving ahead. Composition cannot be altered by any physical means. So here I just drawn iron rod. Okay. Now try to understand the same old image. These are all atoms of iron, correct? Iron atoms are here in the rod. Now one student is interested in this atom and he is asking, ma'am, take this atom out. Can I easily going to do that? So that's what is the next point. Composition cannot be altered by any physical means. So you are not able, you cannot like take out the atoms from one single rod. Correct? So it's not very easy to separate the components or the atoms from pure substances by any physical means, by any physical or manual method. We cannot do the separation of the atoms which are present in the pure substances. Okay. Next, depending on the chemical composition, they are classified as. Try to understand, pure substances are further divided into two categories. First is what? Elements. Second is compounds. Okay. So we have covered what is a matter, classification of matter. Matter is divided into chemical, like it has two classification, physical classification, chemical classification. Chemical classification is based on its chemical composition, and based on that we are having pure substance. Pure substances are further divided into elements and compounds. Is there any doubt, any confusion? Is it hard to understand? Okay. So quickly try to understand all the properties. So pure substance consists of a single type of particles throughout their chemical composition. Okay, so substance is a pure single form of matter. This is what is the, like, pure substance is a very simple form of any matter, correct? It is homogeneous in nature, has a definite set of properties. What those properties can be considered as melting point, boiling point, etc. Composition cannot be altered by any physical, means you cannot change, or you cannot alter its chemical composition. You cannot separate the atoms out from that composition by any physical means. Okay, and depending on the chemical composition, they are further classified into elements and compounds. Is that all clear with you all? If you want to take note of this quickly, you can. Okay, let's move ahead. Now it's time to understand what elements are. Okay, see, try to understand this tree of classification of matter. Okay, now we have moved towards elements. Now what do you mean an element is? Like, what is the definition, how one should know? See, a pure substance which cannot be subdivided into two or more simpler substances by any chemical means is called as element. Okay, so first of all, try to understand element is a pure substance. How? It is such a pure substance which cannot get divided further into different chemical species by any chemical method. Okay, that kind of a substance is known as elements. So try to understand the examples. Hydrogen, H, is considered as an element. Oxygen, O, is considered as an element. Chlorine, bromine, we are having iodine. So students, these are all elements. If you closely see, suppose I am writing sodium, I am writing magnesium, I am writing what? Zinc, tin, lead, okay, potassium. So students, if you will see the examples which we have written here, some of them are metals, some of them are non-metals. Sodium, magnesium, zinc, tin, lead, potassium, these are examples of metals, where rest are non-metals. Okay. So try to understand that when we talk about elements, again we are going to see the further classification. Elements have their own categories, subcategories, such as metals, non-metals and metalloids. Okay, but these are some examples which we use in our daily life. Oxygen, then we are having carbon, then we are having hydrogen, sodium, chlorine. These are some examples of elements. You cannot further divide the substance which is pure. Okay. A substance made up of the atoms with the same atomic number is called an element. Suppose I am taking example of hydrogen, H2 gas. So hydrogen gas is made up of atoms, suppose H1 and H2. These are, let's suppose these are two hydrogen atoms. On combination they are giving you hydrogen as a what? As a gas. These are what? Atoms. Okay, this is a gas molecule. Let me specify it very clearly. This is a gas molecule. These are two atoms. They are getting combined. But where is the catch? See, try to understand the definition once again. A substance made up of atoms, okay, these are two atoms with same atomic number. Definitely, if this is one hydrogen is getting combined with another one, okay, this is hydrogen 1, this is hydrogen 2, okay, it's a bond, okay, so this line is representing the bond. These are two atoms. Definitely, both of them are having same number of electron. correct? They are pure substances made up of same atoms, they are having same atomic number, giving you what? H2, which is also nothing but what? Form of element. So this becomes your pure substance element. Is there any doubt? Is there any confusion? Hydrogen, atomic number 1, 1. Got it? Now next property is that composition cannot be altered by any physical means. Again, yes, even in elements you cannot alter the chemical composition by any physical means. Pure substances further classified into elements and compounds on so here actually we try to understand, like these are the pure images of pure substances, such as I have given one example of gold and iron nails. So these are some examples of pure substances, and we are going to understand that elements are further divided into what? Metals, metalloids and non-metals. So these are further categories where elements are divided into, or they are subdivided into. First is what? Metals, second is metalloids, and C is what? Non-metals. So I have shown you this periodic table here. So when we learn about periodic table, it's nothing but it's a proper arrangement of all the elements in one single period. Okay, so we are having like nature of these elements, either metals or non-metals. Maybe there are some elements which are metalloids. Okay, now what metals are, what metalloids are, what non-metals are, quickly we are going to understand about them. So let's get started with metals. Give me some examples of metal which we use in our daily life. We use gold, silver, correct? We use metals in kitchen also. Stainless steel is an alloy which is made up of so many metals inside it, correct? We use iron, right? So these are some elements which we use in our daily life. They are called as, they are having a chemical word, metal. Now what properties do these metals have? Students, they have tried to focus here, they have luster. Okay, they are shiny in appearance. When we see any substance for the first time, what do we see? Like how it appears. Let me put it here. Yeah, focus here. It's very shiny in appearance. So I can say it is lustrous. Okay, it has that property that it shines. See the iron nails, it has shine too. It is made up of iron, which is a metal. It is a gold, which is a metal. I hope you all are understanding. So students, when we study about metals, first thing is what? They are lustrous. Correct? They form cations. We are going to cover this part later on, but just stay with me and follow my path. Okay, whatever I am making you guys to understand, just follow these properties first. We are going to understand how they form cations and what cations are, etc. Try to understand. They conduct heat and electricity. Okay, so we are having metallic utensils in our kitchen, right? You must have seen when we on the pan, it gets, if you are having any metallic pan which is made up of stainless steel obviously, so that pan is getting heat up, right? When we are putting on the burner, our food is getting properly cooked, because that metallic surface has the ability to absorb heat, correct? Secondly, whenever we see in our home, like we are having wires, copper wires, I said copper is a metal. So you must have seen, like these are small wires which have polymer coating on their surfaces. So through this wire, what happens? Electricity gets conducted. This is what is a property of what? Metal. Alright. Next is they are ductile and they are malleable. So you must have seen, whenever you are going for your school, you are carrying your tiffin box, correct? And you are using aluminium foil. That is, aluminium is a metal, okay, which is in the form of sheet, correct? Also, just now I have shown you wire, okay. So the metal has this property that they can beaten up and they can form thin wires, long wires. Okay, so this is nothing but ability to form wires, which is the property is known as what? Ductility. So I can say so, yes, metals are ductile in nature. We can form long and thin vents or ducts out of them, and that's why the word is duct. Okay, that wire. Then they are malleable. We can form like we can beat them up, and we can have longer sheets, thin and longer sheets. With the help of metals we can form, and we can use them in daily life. That's why we say they are malleable in nature. Who? Metals, right? Example, aluminium, we are having ductility is there, like they are ductile in nature. Okay, so try to remember these properties, ductile and malleable. They can conduct heat, and they can conduct electricity as well. All right, let's move ahead. They are sonorous. I'm sure that's like when you're going to your school, you must have daily you hear or you listen that ringing sound of your bell, which is there in your school, right? Or you must have seen like metallic coins. They are having their own sound when we are going to put them on the floor, right? Sonorous is nothing but ability to produce sound. Okay, this is what is the next property which is possessed by metals. They have tendency to make sound, a pleasurable sound, and that is why we use them in musical instruments. What? Metals. Okay, guitar, and there are some musical instruments which need use of metals. Then what are the examples? Sodium, potassium, magnesium, calcium, copper, iron, Au, Ag, that is gold or silver, right? So these are few examples, and just have a look quickly. This is what your aluminium, iron is there. Just a minute. Okay, then calcium, sodium, we are having platinum, aurum, magnesium and potassium. Just see like how do they appear in the nature. Okay, they are shiny, they are sonorous, they are ductile. Okay, they are malleable, they can conduct heat, and they can conduct electricity. Correct? Is it clear with you all? Okay, so students, we are left with this property known as like they can have they can form cations. Firstly, try to understand what do you mean by ions. So ions are any chemical species which are having any charge on their head, or charge bearing species are known as ions. Now a substance or an atom, when it loses electron, okay, so I can say because of loss of an electron we get cations, and because of the when it accept electron, or on acceptance of electron, we get like anion gets into atom form anions. Okay, we are having an atom, when it is going to lose electron, it is going to form cation. Okay, and if it is going to accept an electron, it is going to form anion. Cations are positively charged. Cations are positively charged, where anions are negatively charged. Okay, so that is what is a brief about what ions and what type of ions we have. So they in case of metals, we have written here that they form cations. Try to understand students, how do they form cations. Suppose I am having an atom. Okay, this is what is the central part of an atom, like metal atom I am talking about. This is what is the central part of any atom. Now this atom is surrounded by some shells. I am going to write one word here. These are some shells. This is what is the nucleus. Okay, so basically when we try to draw an atomic structure of any atom, okay, it has two parts. The central part is nucleus, and it is surrounded by some shells. Okay, they are also called as orbitals. Okay, so try to understand. In nucleus we are having protons and neutrons. Okay. So protons and neutrons are going to stay in nucleus. Now in shells we have electrons. In shells what do we have? We have electrons. Correct? Try to understand, students, when let's suppose this is a metal atom. If this is a metallic atom, ions are going to, like cations, when do we get the formation of cations? When there is removal of an electron, when an atom loses electron from its outermost shell. So if this is what is the outermost shell of an atom, and if this electron is getting removed, or this atom is like losing one electron, one or many electron from its outermost shell, it is going to form cation. It is going to form cation, okay, which is positively charged. Okay. And in metals, metals are having electrons in their valence shell, which are very loosely bounded with nucleus. Okay, this is what is again a specific property which we observe in metals, and that's why it happens to lose electrons which is present in the outermost shell of any metal atom. So it becomes very easy for them, it becomes easy to lose electrons. Okay, and that's why they end up having the formation of cations. Okay. So like what exactly the chemistry behind it, how it happens, we are going to learn it in the next chapter. But as of now, try to understand that to form cation, they are having valence electrons in their valence shell, and these electrons are quite loosely bonded. That's why they are having ability to get out from the valence shell very easily, and that's why they form what? Cations. They form metals form cations easily. All right, is there any confusion, is there any doubt? Okay, so quickly make a note of this, students. Write down the keywords about the metal properties. Got it? Let's move ahead and try to understand the properties which are possessed by the next element, which is what? Non-metal. So now we have just covered all the properties of what? Metals. See, word is saying that non, they are like totally against, or they are opposite in properties from metals. They are not like metals, that's all about it. Okay, so definitely their properties are going to be in reverse manner. So first of all, okay, we are going to understand this later on. Try to understand, they are non-lustrous. Okay, so non-metals such as hydrogen, oxygen, chlorine, bromine, iodine, these are few examples of what? Non-metals, and most of them are what? Non-lustrous, excluding iodine. Okay, this is what is an exception basically, and they exhibit a variety of colors. So this is what is a newly added property here. Non-metals generally show different colors. Okay, also they are poor conductors of heat and electricity, unlike metals. Okay, so non-metals do not conduct heat and electricity. Okay, again here is an exception of graphite. Graphite is nothing but the form of carbon, which is known as what? Allotrope of carbon. Okay, so that carbon is a non-metal, graphite is a non-metal, but it shows conduction of heat and electricity. Why it happens, how it happens, we are going to cover this in carbon and compounds. This is the chapter for us, so we are going to see the chemistry there, but try to understand exception as what? Graphite. They are neither malleable nor ductile. Definitely you are not going to form any sheet or not any wire out of non-metals. That's why they are neither malleable nor ductile in nature. They are non-sonorous. They do not have the capacity or property to produce what? Sound. That's why they are non-sonorous. Example: hydrogen, oxygen, nitrogen, sulfur, carbon, chlorine. These are few examples of non-metals. Okay, just have a look. Carbon, this is how it looks like. Then we are having phosphorus, which is a non-metal, sulfur, okay, which is yellow in color. Okay, so just have a look. If you want to make a note of these properties, quickly do. Alright, so it's time to understand this first property, anions. I told you when we are having a metal, an atom which is neutral, it has not lost any electron, it has not gained any electron. Okay, just now we have seen when metal atom loses an electron, it has actually, metals are having tendency to lose electrons very easily, and that's why they form cations. Anion is quite opposite of what? Cation. I'm sure you must have got it. So yes, here what is happening? Suppose this is a non-metal, it's an atomic structure of any non-metal, and if this is the valence shell, that means the last shell of any non-metal. Okay, so we have to understand that when an electron is getting added, or when there is an acceptance of an electron in the valence shell of any non-metal, we say that a neutral atom is going to transform into what? Anion. It will be now negatively charged ion, which is what? Anion. So that means, in conclusion, I can say that non-metals are having tendency, or they possess a property to accept electron in their valence shell or in their outermost shell. That's why they form what? Anion, negatively charged ion. It's very important. Our chemistry based on this property only, like losing of electron, gaining of electron, sharing of electron. We have a great chapter for that, chemical bonding. So try to understand a little concept here, that metals are going to donate electron. Okay, they are having freely available electrons which they can donate, and that's why they form cation. Okay, and anion are going to accept the electron. Okay, that's why we say they have the property to form what? Anion. Is that clear? Just quickly make a note of, have you all taken the note of these properties? All right. Let's move ahead. We are having third type of element, which is what? Metalloids. So students, try to understand the substances which are the elements which are present in the periodic table or in this universe. They have some properties are from metals and some properties are from non-metals. So we have some elements such as what? Silicon, arsenic, okay, boron. These are some metalloids. These are some elements. They are having some intermediate properties between metals and non-metals, and they are having wide application in semiconduction, and we are having proper study of this metalloids ahead. So try to understand, these are few metalloids, or these are few elements who have got little properties from, some properties from metals or some properties from non-metals. Okay, have a look. This is what is boron. Then we are having silicon. Then see here, it's germanium is there, arsenic, antimony and tellurium. Okay, tellurium. So these are some metalloids. Okay, a single definition and examples. Okay, shall we move ahead? All right. Students, we have just finished about what? Pure substances, and into that we have covered the subcategory which is what? Element. Now elements are further classified into metals, non-metals and metalloids. We have covered elements. Now it's time to move ahead and try to understand the next type of pure substance, which is what? Compound. Okay. So what do you mean by compound? What is the ideal definition for that? So substance composed of two or more elements. Compound is a substance which is composed of two or more elements chemically combined with one another in a fixed proportion. In a fixed proportion. So compound is any chemical substance which is composed of two or more elements in a fixed composition. Okay. So I am going to give you some example, do not worry, try to understand it one by one. So here we have taken example of water. So what is the chemical formula of water? It is what? H2O, correct? So I say that H2O is a compound. It is a compound. On what basis did I say so? Try to understand. We are having two elements here. Just quickly tell me the name of elements. We have just covered about the elements. Yes. Yes, hydrogen and what? It is hydrogen. This is what? Oxygen. Okay. These are what? I'll write here. Elements. Hydrogen and oxygen. So they are combined with each other. Tell me how many atoms do we have in this compound? 2 hydrogen plus 1 oxygen. I can say 3 atoms we have here in this one single compound. So read the definition. Substance composed of 2 or more elements. So basically we are having 2 elements and which is giving you 3 atoms all together in one single compound. Okay. So they are going to react with each other chemically. Their chemical reaction is going to happen, they are going to get combined chemically, and in result we are going to get H2O as a compound. Okay, H2O as a compound. That is half of this definition. Here we need to try to understand what do you mean by a fixed proportion. Focus here. Students, always try to understand that if I want to see this ratio by parts, 2 parts of hydrogen, 1 part of oxygen, okay, and if I am going to give you one ratio such as 1:8 by mass ratio, okay, so by mass, like what is the mass of hydrogen? 1. We are having 2 hydrogen atom, that means 2, okay. Oxygen has, what is the mass of oxygen? 16, right? I am asking you to take out the simplest ratio of by mass, which has to be 1:8. This is what is the fixed ratio for water. It is going to fixed. You take any water sample. Suppose I am asking you to take a water sample from your home. I am going to carry my own water bottle. The water which we have inside it, it has the fixed mass ratio which is 1:8, and that's how we are going to complete this definition of compound. Firstly, it is made up of 2 or more elements chemically with one another in a fixed proportion. Okay, so no matter whichever water sample you are taking, it has 1:8 by mass ratio which is a fixed. Okay, so that is the definition along with an example of a compound. Soon we are going to cover different examples of compound. We are going to understand what different properties compounds are having. Okay, we are going to have a detailed discussion about that. But as of now, it is are you all able to follow till here? We have completed what are pure substances and what are elements. We have just seen a definition along with an example for compound. Is there any doubt? Is there any worry? Alright. So students, in our further classes, we are going to continue with this session. So till then, keep studying and take care.